Okay, ladies and gentlemen, what I would like for you to do is open your notes to where we left off yesterday. Take out your periodic table. We have to go over a couple of things that you will run into on WebAssign eventually dealing with Electron configurations. Now, what we have been writing is we've been writing the full ground state configuration. That, like I said yesterday, has a bit of redundancy because we always start at the same spot. 1s2, 2s2, 2p6. Now, what I call the lazy man's way of doing it is the noble gas notation. So I'm going to show you that because you're going to need to know the noble gas notation for WebAssign. Now, I rarely use the noble gas notation. Okay? I write them all out. If you happen to use the noble gas and WebAssign wants the full, it's going to mark you wrong. Okay, so if you think, well, I'll just take the shortcut and I won't do that, well, WebAssign will mark you wrong. So just to let you know that. Now, if I'm looking at bromine and writing the the electron configuration for bromine, I would write it as so. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. That's the full electron configuration. Now, when we're writing the noble gas configuration, all right, when we're writing the noble gas configuration, we look at the noble gas that is before the element. So bromine is element number 35 on my periodic table. What is the noble gas before 35? Argon, number 18, right? So when I'm doing the noble gas notation, okay, I can put argon in brackets. Now, what that does is that takes care of all of this right here. Because if you look up on your periodic table, what element is 3p6? Argon, right? Argon, 3p6. So, I have all of that taken care of with this right here. So then all I need to do is finish it out. 4s2, 3d10, 4p5. So that is the noble gas configuration. And I have it right there. Put the noble gas before the element in brackets, and then continue on from there. Yes, ma'am. To know that it's argon. How to get to argon? What do you mean just use those numbers? Okay, we'll talk here in a second, okay? Let me go on and do the rest of this WebAssign stuff. Now, here is the second thing we're going to talk about, and boy, do I have a bundle of boxes here. And I'm going to tell you this, give you a hint. When you are doing your entrance slip today, you should think of things as in terms of boxes like this. That's my little hint for you today. Now, we're looking at copper here, and we need to talk about transition metals. Now, find copper on your periodic table. Copper is right here, number 29, correct? Now, I am going to fill my orbitals like I would for copper. So I know that copper has 29 electrons, and I'm going to obey my Hund's rule and everything. I've already wrote out all of my orbitals, so I'm going to add electrons the way I should, obeying my Hund's rule. Here I've got equal energy levels, so I'm adding one at a time till I double them up. Here's only one energy or one orbital, I can double it up. Here's 3 of the same, so I've got to add one before I double up. Okay, so right there I'm at argon, if you would hang with me. Now I am going to copper, so I'm going to fill my 4s. And we haven't dealt with the 3Ds yet in terms of orbital. But notice that I have 1, 2, 3, 4, 5 d orbitals, right? Because I know that 5 d orbitals hold 10 electrons. They are all of the same energy, so I'm going to add one at a time. So I'm going to add 1, 2, 3, 4, 5. Now I can double up. And when I double up, I believe if I count all those out, I've now written the orbitals and filled those in for copper. Now, the thing that I want to show you is that copper and certain transition metals, okay? Remember, transition metals correspond to the D block, right? Certain metals in the D block like to work in a little bit different ways. And what do I mean by that? Well, they have greater stability, and their energy is better if they fill all of these d orbitals here. So what you're going to see happen is they're going to take an electron out of that 4s orbital, and they're going to fill the 3d orbitals. Okay? And it all has to do with stability and energy. Now, you might say, well, how am I supposed to know that? Okay? How am I supposed to know that? Well, look at your periodic table. Turn to the side that has the name in red and find copper. Right above the name in red on copper is an electron configuration, correct? And that electron configuration has the noble gas notation, correct? So if I'm writing this, and I'm going to write just the noble gas notation for this, I look at my noble gas before copper, and that's going to be argon 2. So if I'm writing my noble gas notation, in brackets I'm putting argon, and then they will have something like this, and it's going to be backwards because I told you the periodic table that you have from Ward's is not the one, not the electron configuration that we teach here. So it's going to say something like 4s1 3d10, correct? Is that what it says? Now, we would expect it to say 4s2 3d9. However, what is happening is that electron from the 4s is transitioning over there to fill that d orbital. That's all you need to know. You don't need to know why it's doing it. Just know that it's doing it. That is why we're calling them the transition metals. Okay? It's transitioning that electron to a different orbital. Now, look at your periodic table. Okay? Look at period 4. Can you find another one of those that does that on period 4? Yeah, Colton? Chromium. How did you know it did it? It has the 4s1 again, right? Where we'd expect it to be 4s2. So, funny how I led you right into the very next one I'm going to do. Chromium. Now, I just showed you on this one and said they like to fill these d orbitals with 10 right here. Well, sometimes it'll happen where we can fill those orbitals and not even, well, let me go back, not even fill the orbitals totally. Chromium is 24. So when I'm adding my electrons, I'm adding them. Hund's rule, once again. I'm at 18, 19, 20, 21, 22, 23. Is that right? 18, 19, 20, 21, 22, 23, 24. Okay. I knew where I needed to be. My counting's maybe a little off. But here is the way that you would expect to write this. So you would say that I have argon, and then I have 4s2, 3d4. But once again, like I said, this is one that transitions that electron. And this time, it's not to fill up any orbitals, but it's to make sure that I don't have this empty seat right here in the d orbital. I have that empty seat there. It doesn't want it, so it's going to transition or an electron from that s2, that 4s2, to that 3d. All right? So, when I write my electron configuration, I'm going to have 4s1, 3d5. Once again, the transition metals. Now, find another one. Find another one. And if you find one, raise your hand. Let's see if you're right. Yeah, okay. What? Gallium? Gallium is not. Gallium's in the P block. Okay? Transitions in the D block. There are no more? Huh? Silver. Let me look at silver up here. Yeah, excellent. Silver has a bracket with krypton and then 5s1, 4d10. So silver, yes indeed, would be another one. Good. So are we okay with how to recognize these transition metals? Because if you do it without transitioning that, and I mean the 4s1, the 3d5, then you'll get it wrong on WebAssign. We know how to recognize those on the periodic table. Good. Well, let's move on then. Here is one of the last things we're going to talk about. We're going to discuss the inner and the outer levels. We have these things that we call energy levels, the principal energy levels. And we know that they correspond with the periods on our table. Now, where on our periodic table do we have full energy levels at? Where are the energy levels full? Yeah. The noble gases, right? And the noble gases are all ending in a P6, right?
Ron,
Yeah.
do you have Matthew sample?
Yeah.
Did you say it down at the signing out?
I sure will.
Thank you.
So we're looking for those P6s. right? So I see a P6 right here. I see a P6 right here. I see a P6 right here. And I know that this guy right here is helium. And I know that helium fills. So right there, I have 1, 2, 3, 4, 5 full shells, don't I? So those could be called inner energy levels, okay? Because those are the full shells. The outer energy level is going to be the one that is not filled yet, okay? Or I guess it could be have a 6p6 here, and we could consider that outer because it would be filled, but it's still the outside energy level. Okay, it is the last energy level, which we call the outer or the valence. And we'll talk about valence electrons when we deal with bonding coming up next chapter. Okay, so inner energy levels would be those here. The outer energy level would be the very last energy level that we have. Questions about that? All right, the final thing you're going to need for your WebAssign are these things right here. And we've already talked about these a little bit. We've talked about the bottom one to tell how many electrons are on a specific energy level. Well, we take the energy level squared and multiply that by 2. To get the number of orbitals on that particular level, we would take the N, the main energy level, or the principal energy level, and square that. So, we know that the first energy level only has 1 orbital, and that's an s orbital, right? So, what is 1 squared? 1, right? So that tells me right there the first energy level only has 1 orbital. Okay, what's 1 squared times 2? That's 2, so it would hold 2 electrons. Now, if I look up at the second energy level, I see that I have a 2s orbital, and I have 3 2p orbitals, don't I? So what is 3 and 1? That's 4. Well, what's 2 squared? 4. 4 orbitals. Each orbital holds 2 electrons, so how many electrons on the second energy level? 8. Now, the third energy level is where it gets a little bit trickier. Okay, and we're going to end with this one. The third energy level. Remember that on that third energy level, that I have S's right here, I have P's right here, but aren't these 3 D's? Yeah, they are, right? So I have 1 orbital and 3 orbitals make 4, and then 4 and 5 d orbitals make 9 total. Well, what's 3 squared? 9. What's 3 squared times 2? 18. So it's 18 electrons. So that is this for orbitals, this for electrons, and you're going to need to be able to do that for WebAssign. Okay? Any questions? Yes? Yep. Oh, you just need to copy? Okay. Nope. My bad.